Section 18-4 introduces something called the common mode rejection ratio. Before we can discuss that, we need to know what a common mode signal is. So the differential amplifier is called that because when you apply a differential mode signal, that gets amplified. So a differential mode signal is when you apply a different voltage between the two inputs. So here I've got a sine wave, and that signal is applied between those two inputs. So I'll see a different voltage at this point than I'll see at this point. That'll get amplified by the gain factor, which is calculated by dividing the feedback resistor by the input resistor. So in this case, it's minus 10K over 1K. The gain of this circuit is minus 10 times bigger. Now, when we apply a common mode signal, what we're doing is we're applying the same voltage to both inputs. So the difference between the inputs is 0 volts. Well, if we multiply that by 10, which is the gain factor in this one as well, Vout becomes 10 times the difference between the two input voltages. But because they're the same voltage, that should be 0 volts. So the output from a common mode signal should always be 0 volts if you have perfect op-amps. And they try and make op-amps perfect. When they implement this on a single piece of silicone, the transistors on the inputs are pretty well matched, but there can be subtle differences between them. And those subtle differences mean that if you apply a large enough signal to the input, you may see a tiny little bit of the sine wave coming out. So in this case, the common mode signal can get through because of differences on the input. The other problem is that we have these resistors here, and they may not be exactly 10.000K. They may be off by plus or minus 1%. Even if you use a 1% tolerance resistor, the difference between this 10K and this 10K and this 1K and this 1K can result in a larger sine wave coming out, even though it's supposed to be 0 with a common mode signal. So the text shows you how to calculate a common mode gain given slight variation in resistor values. I think that process is a little tedious. So let's talk about how we would go about measuring what the common mode gain given an input signal and output signal on an op-amp. Now the common mode signal, if it's applied to both inputs, we're supposed to get a dead flat line out here. So in order to get any kind of a sine wave to sneak through, we need to put a pretty large signal on the input, and then we might see some sine wave coming out of the output. So let's put something like 20 volts peak to peak on the input, as big as we possibly can. So we might get something like 2 millivolts coming out the output of this op-amp. So now we can calculate what the gain is when we apply a common mode input voltage. So AVCM is Vout over Vin. Well, we put 20 volts peak to peak in, and we're getting out 2 millivolts peak to peak out. So that means we're getting out 1/10,000th of what we put in. And that's equal to 0.0001. So a common mode gain is less than 1, and it's called an attenuation. So let's summarize where we are at this point. So the differential mode signal, which is AVD, that we figured out was minus 10. When we put in a differential mode voltage, we get a signal that is 10 times bigger on the output. Now the common mode signal, which is what we calculated down here, AVCM, that is multiplied by 0.001. So this is our common mode gain. So our differential mode gain and our common mode gain. What is the ratio between them? How many times bigger does it amplify a differential signal versus reject a common mode signal? This is what's called common mode rejection ratio. So let's summarize this. When we want to amplify a differential signal, we put in a medium-sized signal, let's say 1 volt peak to peak. And what we hope to get out is something bigger, let's say 10 volts peak to peak. So the differential gain of this one which is AVD, is V out over V in, which is going to be minus 10. Now for a common mode signal, we want to reject the common mode signal. So when we put in a large signal, let's say 20 volts peak to peak, we want to get something really small out, let's say 2 millivolts. So the AV common mode is V out over V in, which is 2 millivolts over 20 volts, which is 0.0001. And the ratio between those, how well it amplifies a differential signal compared to how well it rejects the common mode, is called the common mode rejection ratio. So CMRR equals AVD over AVCM, which is 10 times over 0.0001 times. That's going to be 100,000 times better. So basically, the differential signal, it's the same circuit, but it amplifies a differential signal 100,000 times better than it amplifies the common mode signal. So we say it rejects the common mode signal. CMRR can be written in one of two ways. We can write it as a linear value and say that it amplifies the differential signal 100,000 times better than the common mode signal. We can also write it as a decibel value, where we'd say Cmrr Db. And in that case, we would take the log of the 100,000 and we would multiply it by 20. Log of 100,000 is 5, so this would be equal to 100 dB. So what is common mode rejection ratio trying to tell us? Let's imagine that you've got a recording studio and you've got the singing artist belting out a song into a microphone. The microphone is just a voltage source that generates a couple of millivolts of signal, which it delivers to the line through about a 1K ohm output impedance. Now it goes into the line here and it has to pass under the floor and then make its way into the recording section of your studio, where it gets amplified by a differential amplifier, and that gets put onto tape. Now, when it goes under the floor, the wires may pass by various motors and stage lights and things that will couple noise into the cable taking the microphone signal to the recording section. But because it's a twisted pair, they're held very closely together, and the same noise level gets put into both wires. So it gets that into there and that into there. These two signals end up at the input of the differential amplifier with the same amplitude. Therefore, it's a common mode signal and it will get rejected. The microphone signal, which is the good stuff we want to get through, that's a differential signal, and that'll end up here at the input as a difference voltage, which will get amplified. Common mode rejection ratio is an expression of how well the good stuff is amplified and the bad stuff is blocked.